fine and well, and take necessary precaution at your home against COVID-19. So we are studying chapter number 9, that is force and laws of motion. That is also chapter number 2 of physics. We have total 3 parts in our science, that is physics, chemistry and biology, and we have little portion of environment science also. In this lesson number 9, till the time we have seen what is cause of motion, how we can change motion or say velocity of an object, what is inertia, what is cause of more and less inertia, what are the basic laws of motion, who gave these laws of motion, and we have seen first law of motion, that is also called as law of inertia, and second law of motion, and few example and some real life situation related to second law of motion. In the last lecture we have seen example number 9.1 to 9.4 and also derived how second law can be deduced to first law mathematically. So today's session we are going to start with numerical 9.5. What is the data given here? We have one graph. You can see this graph is velocity versus time graph. Now you know from chapter number 8 that the y-axis is velocity axis and this x-axis is time axis, and we always read graph as y versus x graph. Here we have velocity on y-axis and time on x-axis. So we will read this graph as velocity versus time graph, as we can read y versus s graph. And we have also write unit of both this quantity. Here time given in second and velocity given in centimeter per second. Remember the unit centimeter per second is given here. That is not SI unit of velocity. So remember we have to convert all the unit in SI unit. Here the velocity time graph of ball of mass 20 gram moving along the straight line on the long table is given in figure. So we have one figure, that is velocity versus time graph of 20 gram of ball that is moving along straight line. So what we have to find from this graph, how much force does table exert on the ball bring to rest. So we have to find force to stop this ball from velocity 20 centimeter per second to 0 centimeter per second. To solve this example, first of all we have to read this graph. So let me write given data first. We have ball of mass 20 gram. Okay, and we have to find force applied by table to stop this ball, which means at rest position. So let's read this graph first. Here we have velocity axis start from 0, 5, 10, 15, 20 and so on. And here we have time axis in second 1, 2, 3, 4, 5 and so on. I can derive initial velocity u. I can derive initial velocity u. That is, what is initial velocity? Initial velocity is nothing but the velocity at 0 time. So I can see from the graph at 0 second ball has velocity 20 centimeter per second. So I can write here 20 centimeter per second. Now, what is the velocity at rest? We all know that velocity at rest is nothing but 0 meter per second, or say 0 centimeter per second. To this initial velocity to final velocity, or say rest position, this ball takes time of 0 to 10 seconds. That is, time is 10 seconds. So now we have all given data with us by reading this graph. We derive initial velocity, that is 20 centimeter per second. What is the time for initial velocity? That is 0 second. Final velocity, that is at rest position, and time for this velocity gain is 10 seconds. So what we have to find here? We have to find force. Force exerted by table on ball. We have only one formula of force, that is F is equal to ma. Let's see, we have all values or not. We have F here that we want to find. We want mass for that. We have mass? Yes, we have mass. A, that is acceleration. We don't have acceleration, but now from past 4 example, we know that we have formula of acceleration, that is V minus U divide T. V is final velocity, U is initial velocity and T is time. Now you can see we have all data with us, but here the data is not in SI unit. So first I have to convert this data into SI unit. So 20 gram mass is equal to 20 gram. So I have to convert this gram into kilogram. So what I need to do, I have to divide this with 1000. So I have m is equal to 0.02 kg. What I need to do, I need to shift decimal point to left side. Shift decimal point to left side. How many points? 3 points, cause I have 1000 in denominator. I hope you know this thing. I have decimal point here. So 1, 2 and 3. So I have now decimal point here. So I have 0.02 kg as mass of this ball. So I have m now. Now I have to convert this u into meter per second. I have u as 20 centimeter per second. So to convert this centimeter to meter, what I need to do? I need to divide this with 100, because we know that 1 meter is equal to 100 centimeter. So I get this in meter per second. This 0 will be cut and I have 0.2 meter per second as initial velocity. Now I put this value, m is 0.02, v is 0 minus u is 0.2 divide time I have 10 second. This second is already in SI unit. So I need not to convert this time in SI unit. So I have 0.02 multiply minus 0.2 divide 10. So I have 0.02 multiply minus 0.02. What I did? I shift this decimal point to left side. Why? Because I have 10 in denominator. So I will multiply 0.02 and 0.02. Now we know that 0.02 is 2 divide 100 into 0.02 is 2 divide, that is minus 4 divide 10,000. So shift this decimal point. Which decimal point? This decimal point left side by 4 place. So I have force is equal to 0.0004 Newton with this minus sign here. Don't forget to put this minus sign. What is significance of minus sign? Now we have seen from past example, this negative sign means friction force is opposing motion of this ball. So any force that is supporting motion will be positive, and any force that opposes the motion will always be negative. So here we have F is equal to minus 0.0004 Newton, as this force is opposing motion of ball. And remember one point I have told you in last session, whenever velocity is decreasing, whenever velocity will decrease, force will be negative, and when velocity will increase, force will be positive. So I hope you can remember all this point and correlate all this example with past example. Let's do one activity. What I do, if I will hit on this board like